Okay. So before we get started, few announcements. So tomorrow there is a separate session for quiz 2. Sir, I thought the Excel type questions would come in quiz 2. Okay, Excel type question. What do you mean by that? Excel type questions? Because we don't have access. You don't have access to Excel in your exam centers. Thought the Excel type questions would come in quiz 2. Which kind of Excel? Okay, so you will not be asked to solve problems on Excel because you don't have access to Excel. So it will be more of computation and little bit of theory. Okay, so don't expect anything to be solved in Excel because you will not have an Excel sheet there. Okay, so tomorrow you will have a session on quiz 2 discussion. Today we will not be talking anything about quiz 2. Hold it, and tomorrow Malolan will answer all your questions. Then we will meet next week and week after. Today we will complete logistic regression, and next week we'll do data envelopment analysis, and finally we'll have a session on conjoint analysis. And few things from my end are pending. I forgot to upload the last week's Excel sheets to your course portal. So last week we spoke about multiple linear regression, right? We spoke about VAF, the assumptions of linear regression. Then there was an extra session on Gradio demo. So those things, I haven't uploaded those Excel sheets to our course portal. So tomorrow I will do those uploads, and I'll also upload today's Excel sheets. Okay. So with that, let's get started. So today we're going to talk about logistic regression. What is logistic regression? Let me share my screen. Yes, you have studied this enough, right? In many courses, they have covered logistic regression. What is this? Am I audible, first of all?
Yes, sir.
Okay. So tell me something about logistic regression.
So it's a classification algorithm
Yes.
using sigmoid functions,
Super.
usually used for classifications.
Classification. So why do you call it a classification? Because your target variable is categorical in nature, right? It is categorical in nature. And you spoke about something called sigmoid. What is the sigmoid actually?
For
What is this?
linear, it is linear. It is straight
Mm,
line. This is
mm.
a S curved, right?
Okay. All right. So from now on, use the correct words, right? Sigmoid is called an activation function. Have you heard of this term, activation function? Okay. Okay, if you ping me or if you raise your hands, I won't be able to see because I'm sharing screen and I'm writing. So whenever you have anything to say or you have some doubts, please unmute and talk. Okay. Because I won't be able to see if you're raising hands or you're messaging something. I'll have to stop screen sharing and then go there and see all those things. Have you heard of this term called activation function? What is this activation function? So sigmoid is something that you've seen. Any other activation function you've seen in deep learning course or advanced ML something? Have you heard of this? Right, ReLU, leakage ReLU, and so on.
Tan
No,
hyperbolic.
Yes, tan hyperbolic. What do they do?
I haven't heard, sir.
Okay, they will introduce some kind of non-linearity into your function, and we will. You have only seen sigmoid here, but keep a note of this. So tomorrow there is a reason why I'm introducing a lot of keywords during live sessions. Tomorrow, when somebody is using this term called activation function, it shouldn't be Greek and Latin to you. So whenever you hear some keywords, right, you are going to hear a lot of keywords, and keep a note of them. And whenever you have some free time, do a Wikipedia level research of those keywords. That's more than enough. And with time, you will be understanding each and everything in more detail. Okay. So what is the need of sigmoid function? Why can't you use linear regression for classification problems?
Because that will be a continuous. This is discrete.
What is discrete?
Uh,
Continuous?
so linear regression, we use it for continuous data.
Okay. Okay. So that is what you say. Okay. So what is your sigmoid function actually? Sigmoid of x is equal to 1 by 1 plus e power minus z. And what is this z? It is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on, right? So here when we here actually this is linear regression. You see this is actually the equation you use for solving a linear regression problem. When you do the same equation here, right? In classification, especially logistic regression, your output is probability. Your output is actually probability. And what are the axioms of probability? It should not be lesser than 0, greater than 1. It should be between 0 and 1. When you use this, you might end up getting probabilities that are lesser than 0 or greater than 1. So that's the reason why you need a more sophisticated activation function than linear regression for solving this kind of a problem. Because the axioms of probability are very strict. There are no loopholes. You cannot have probability less than 0 or greater than 1. All right. So with and what is this sigma? Can we have write it better? Probability of y is equal to 1. Right. You can say given x. Right. All right. So with this, I'm not going to give you a lot of theory because I'm going to focus more on the exam point of view. Is that okay?
Sure, sir.
Okay. So let's solve this. Let's solve this. Okay. So I'm having two things here: actual and predictions. So these are the actuals. These are the predictions. If I give you these two columns, will you be able to compute accuracy, precision, recall for class P and class F? Imagine P means pass, F means fail, and so on. Will you be able to do that?
Yes, sir.
How will you do that?
We have to find out the true positives, true negatives.
Yes, beautiful. So what is this one? Actual is pass,
True
prediction is
positive,
also pass. It is true
positive.
positive. What about the next one? True positive. Next one is also true positive. So the actual is pass, your prediction is fail. What is this?
False negative.
False negative. Next one is also true positive. Next one is false positive, false positive, true negative, false positive, true negative. Is it correct?
Yes, sir.
So how many true positives do we have? Four, I guess. Right. So there are. Let's have something here. True positive, true negative, false positive, false negative. So we have four true positives, true negatives. Right, I think two, false positives, three, false negative is one, I guess. So if I add up, I'm getting 10, and we do have 10 here. Okay, I think it is correct, and correct me if I'm wrong. And you know the accuracy. What is it? Accuracy. So it is true positive plus true negative divided by sum of all these guys. Okay. What is precision of class P? What is the formula for that? I'm sure you know. What is the formula?
Positive divided by two negative.
Okay. So let me write it here. Okay. So precision of the positive class. Precision of the positive class. Okay. It is true positive by true positive plus false positive. Recall of the positive class. What is this? True positive by true positive plus false negative. Okay. So remember this. In the positive class, if you have if you take P for precision, you will have P here. Okay, so that's how you can remember it easily. So this is true positive divided by true positive plus false positive. Okay, next is true positive by true positive plus false negative. Okay, so this is for positive class. What about the negative class? Precision and recall of negative class. Anybody knows the formula?
True negative or true
So
negative.
maybe the positive we will place negative. Yeah, same thing.
Uh, so recall of negative class will be true negative by true negative plus false positive. Good.
Of course,
Good.
positive.
We already saw this. Let me delete. Okay. So this is true negative divided by true negative plus false negative. This is true negative divided by true negative plus false positive. Okay. Is this easy? Was this easy? Given actuals and predictions, you will have to tag them as true positive, true negative, false positive, false negative, create a confusion matrix, then compute accuracy precision for respective classes. Is it easy? Will you be able to do it?
Yes, sir.
But will Malalan ask such simple questions? Do you think Malalan is going to ask you such simple questions?
No, sir.
Yeah. So we will complicate this little further. Okay. So let me, okay, let's check the numbers 60, 60, 57, 80, 67, and 40. Yeah. So, okay. So if you remember in the last class, I remember giving you a small homework. How do you interpret beta naught, beta 1, and beta 2? Did anybody do that? Anybody work on it? It's okay if you haven't. We will see that in detail now. Anybody had a chance to understand the coefficients of a logistic regression, how to interpret them? Okay, so I take it as a no. That's okay, but it is important. Please don't ignore this topic. It's a standard interview question. So whenever you go for an interview, uh, this is a definite question: how to interpret logistic regression coefficients. I can even say that I recently attended an interview and they asked me this question. Okay, so we do model building and then we compute few things. What are those? Beta naught, beta 1, and beta 2. Assume you were building a logistic regression model. You got beta 1, beta 2, beta naught. Okay. So beta 1, it represents log odds, log odds, right? Baseline probability or something when your x1 and x2 equal to 0, right? Similarly, beta 1 also represents log of odds. It represents the change in log of odds of the outcome y is equal to 1, y is equal to 1 for a unit increase in x1, assuming x2 constant. X2 constant. Okay. Is there a rubber? Okay. Right. From this, can you say beta 2? Can you define beta 2? So if you are increasing x1 by 1 unit, the log of odds of the outcome, which is y is equal to 1, changes. That's what beta 1 signifies. Similarly, for beta 2, can somebody try? It's the same definition. Instead of x1, you will have x2. Instead of x2 as constant, you will have x1 as constant. That's all. But can you interpret log of odds? Can you interpret log of odds? No, it is difficult. So what you do, from log of odds, you compute something called odds ratio, right? So let's say I am giving you your beta 1 is equal to, how much can we say? 0.7, right? So how will you interpret this? This is log of odds ratio. So now take the exponentiation. So e power 0.7. This will be approximately equal to 2.01. Okay. So now what happens, right? If you increase x1 by 1 unit, assuming x2 constant, right? The odds of change in the outcome increases by 2.01. Is this fine? Is this fine? Previously, it was log of odds. After taking exponentiation, you are converting log of odds into odds. So this is more interpretable. Take the exponentiation and you get 2.07. So for a unit increase in x1, which is your feature, the odds of the outcome changes by 2.01 times 2.01, assuming the other variable to be constant. Is this fine? Can we move on? Some yes, no.
Yes, sir.
Okay, great. So now let's go to the Excel. So assume we did logistic regression and we got these coefficients. So how do you calculate Z? What is Z?
Hello.
Yes, please, madam.
Sir, can you explain log of odds a little more?
Yes, sure. Okay. So this is what you, whatever you compute from logistic regression, that is log of odds, right? So here, if you have to interpret your beta 1, it is nothing but you have a feature called x1 and x2. So let's say your house of the square feet is 2000 square feet. If you increase the square feet by 1 unit from 2000 to 2001, how will your outcome change? That is what I'm asking. If you increase, say, your age from 35 to 36, right? 1 unit increase in a variable, what is the changes it is going to bring in your outcome, right? If the age goes from 35 to 36, the change in the log of odds of the outcome will increase by this beta 1, assuming the other variable as constant. That's all. So since this log of odds is not very interpretable, what you do, you convert log of odds to odds. So that's why I took an example of 0.7. Beta 1 is equal to 0.7, and taking exponentiation of 0.7, you get 2.01. So now what I'm saying is, if you increase this x1 variable by 1 unit, the odds of the outcome, right, is going to change by 2.01, assuming the other variable is constant. That's all. I'll do one thing. I'll try to give some practice problems in this area, right? So let me formulate some practice problems so that you are more comfortable on this. Okay. And any doubts, we'll take it on discourse. Is it fine? Let me note it down before I forget. Some practice problems.
So it will change by 2.01 means it will add up to 2.01 or how it will change?
You think about it. Think about it. How it will change. It's going to affect the outcome. This 2.01, take it as a homework. Think about it. So you know that your outcome is going to be 0 or 1. So now if I say 2.01, tell me what is this 2.01. Think about it a little more. On logistic regression coefficients. Okay. Okay. So next one is, what is this Z? Similar to regression. You will see beta naught plus beta 1 into x1 plus beta 2 into x2. Okay. So let me reference these coefficients f4, f4, and f4. No, wrong one, I guess. Right. Okay. So you got Z. You can compute Z for all the 6 observations. Ignore this customer ID because it is unique for each and every customer, and this will not come into model building. So what is happening is, assume this as your test set. You had a training data set, and from the training data set, you computed beta naught, beta 1, and beta 2. With this beta naught, beta 1, and beta 2, you're first computing Z. And how will you compute probabilities? 1
1
by,
upon 1 plus e to the power minus z.
yes, 1 plus e power minus d2. Okay. I think I missed an equal to here. I think this is okay. So let me drag this. What will you do with probabilities? What will you do with probabilities when you have a threshold? So if this is greater than this threshold, which is 0.4, let me reference this. Then you call it as 1, else 0. Is it okay? Is it okay? So you have 1, 1 and rest 0. This is your prediction. Is this fine? Any doubts so far? Any doubts so far? We'll go to the interpretation part next. I just want you to focus on the methodology. If somebody gives you a testing set and they give you the coefficients, you should be able to compute probabilities. And when somebody gives you a threshold, you should be able to tag it as a 1 or 0. Is that fine?
Yes, sir.
Okay. So now, if somebody gives you y underscore actual, will you be able to tag it as true positive, true negative, false positive, false negative?
Yes, yes, sir.
This will be given to you actuals, and you are computing the predictions. And once you have this actuals and prediction, it is similar to this one. Once you have actuals and predictions, you will have to tag them as true positive, false positive, true negative, false negative, compute accuracy, precision, and so on and so forth. Okay. So now tell me, what is the purpose of this threshold? When will you increase? When will you decrease? Okay. So before that, let us do some theory. Okay. Okay. So we saw that, can you define this true positive? Tomorrow in interviews, right? When somebody asks you what is precision, you cannot be telling them true positive by true positive plus false positive. How do you define precision? Can somebody attempt to define precision?
I mean, from the words, precision means maybe the accuracy to an extent. But theoretically, I don't know. I'm just
Okay.
interpreting the word precision.
Okay. So let's first let's do it for positive class alone. Right? Positive class. Let me write the formula again. Precision of positive class is equal to TP by TP plus false positive. Let me also write the definition here. The proportion of predicted positive class y is equal to 1 that are actually positive. Okay. Similarly, recall of positive class is equal to TP by TP plus Fn. Right? Again, the definition could be proportion of actual positive class, actual positive class y is equal to 1 that the model identified correctly. Right? So precision generally deals with the actuals, the actual positives. Recall actually deals with the proportion of positive class that were identified correctly. So this is with respect to your model building. This is with respect to your actuals. Okay. So you know that this is the formula for. Let's only take positive class for now. TP by TP plus FP. I'm going to give you two situations. Okay. So predicting an email as spam or not spam. Then there is another case where we have to the patient, predict patients suffering, say cancer or let's say not cancer. So tell me, in this situation, which is your important metric? You know three important metrics: accuracy, precision, and recall. Right? Ignore accuracy for now. Tell me which is more important here, precision or recall. Similarly here, precision or recall. Which is more important in this setting? Which is more important in this setting? And you have to tell me intuitively.
The cancer case, the prediction, the precision is very important.
Precision is very important. So
Okay,
again, what is the formula for precision? If you see here closely, so precision, you say, also take a look at the formula and then tell me once again.
For cancer, it is recall
Hmm.
because we want to reduce the rate of false negative.
So what will happen if there are a lot of false negatives for cancer predictions? What is false negative in cancer prediction?
Uh, like they don't have cancer, but
Hmm.
actually they have the disease.
Okay, so can you rephrase it? You're almost there, 99% correct. Can you rephrase it? What your model says? What is your model telling for false negative? Cancer or not cancer?
Not cancer.
not cancer, but actually patient is having cancer. Okay, so what is your model telling? Model is telling the patient is not suffering cancer, but the patient actually has cancer. So this is dangerous here. So therefore, in this setting, you have to reduce false negative and increase your recall. And note that these guys are inversely proportional. When you increase recall, your precision will come down. It's a trade-off between recall and precision. For this setting, recall is more important than precision. Now come to this example. Here, which is more important, precision or recall? Which is more important?
Precision.
Okay, so if precision goes high, recall will go down. Why is precision important here? What is a false positive in this setting? Explain
Uh,
false positive here.
Spam mail, but identified as non-spam.
Is that false positive?
Non-spam identified as spam.
Yes, non-spam identified as spam. So let's say you are getting an important email from CEO, and unfortunately your model is predicting as spam and just deleting it or sending it to trash, right? So in this setting, precision is way more important than recall, right? So it depends on setting to setting. You will modify the threshold for achieving a particular metric, right? When precision is more important, you will do the threshold accordingly. When recall is more important, you will tune your model accordingly. But all these things you should be very clear as a business analyst. First of all, when you get into a logistic regression problem or a classification problem, you will have to understand which metric is more important here, precision or recall. Both you cannot achieve, right? One has to be very high, other one has to be compromised slightly. Okay, there will be some cases where both are important. In that case, what you will use? Which metric you will use?
Accuracy.
Hmm? Yeah,
Accuracy.
accuracy. One more metric is there. Have you heard of this term, F1 score? It's a
Yes, sir.
harmonic mean of precision and accuracy. Precision plus recall. So if both are important, use F1 score. All right. So this, so far what we saw was a binary classification problem, which is very easy. So now let us get into a slightly more difficult setting. By the way, what is sensitivity? What is specificity? What is this?
So positive precision is sensitivity and negative recall is specificity.
What you have? Positive precision?
Yes, sir.
No. Positive recall is sensitivity. Negative recall is specificity. What is the formula for this? TP by TP plus Fn. What is the formula for this? Tn by Tn plus Fp. So tomorrow, what will happen? Sometimes we will just say compute sensitivity. We haven't told you whether it is positive class or negative class. Many times it won't be given in the problem, right? You look at your previous year question papers. If somebody says sensitivity, you need to know that it is associated with the positive class. If it is mentioned as specificity, you know that it is associated with the negative class. Okay, we be very mindful of these things. Okay, with this, let us go to a slightly more complicated setting. Right? I'm going to have three classes. It's a three-class problem. We'll have urgent, right? We'll have normal, right? We will have spam. Again, urgent, normal, spam. say urgent, spam. So this will be your predictions, and this will be your actuals. Okay, let me also populate this matrix. 8, 10, 1, 5, 60, 50, 200, 30, and 3. So I am going to ask you a question like, what is the precision of urgent? What is the recall of normal? What is the precision of spam, and so on? How will you compute this? Any idea? There are many techniques. So one technique that is predominantly used is called micro averaging. Right? Micro averaging. Have you heard of this? Right? It is like converting a 3-class problem into a 2-class problem and solving it. Okay. How will you solve this? Okay. So first of all, tell me what is urgent, comma normal. Similarly, spam, comma urgent. What is this? Row and column. Row and column. Urgent, comma normal is 10. Spam, comma urgent is what?
3.
3.
Yes. That's all. That's all. So now let us solve this for which one? Let us solve this for urgent. Okay. So now I'm going to convert this 3-class problem into a 2-class problem. How will you do that? Any idea? Spread underscore urgent. Right? Spread underscore not urgent. Right? Actuals underscore urgent. Actuals underscore not urgent. Right? So what is spread underscore urgent? And actual underscore urgent? Prediction is urgent, actual is also urgent. How much it is?
8.
Right? Prediction is also urgent, actual is also urgent. It is 8. So what is prediction not urgent? Actual also not urgent?
260.
So it is 200 plus 50 plus 60 plus 30. What is it? 340, 250, 310, 340. Is it fine?
Yes.
Okay. What is next? Prediction is urgent. Actual is not urgent. How much it is? Prediction is urgent. This
11.
first row, actual is not urgent. How much it is?
11.
10 plus 1, 11. What is this one? Prediction is not urgent, but actual is urgent. How much it is?
8.
8. So with this, will you be able to calculate precision and recall? When you have this confusion matrix in the standard format, what is precision? What is precision of positive class? TP by TP plus FP. What is recall? Positive class? TP by TP plus FN. Will you be able to do it?
Yes, sir.
Is it clear? Okay. So let's do this on Excel so that it is little more clear. I know this is not clear. Let me populate this, zoom a bit. We'll calculate for one more class and then control. So I'm going to call urgent normal, spam. Similarly, urgent, normal, spam. So these are predictions. These are actuals. Okay, so this was how much? 8, 10, 11. Sorry, this is 1, 5, 60, 50, 5, 60, 50, 233. 3. Okay. Okay. So now let us go. Let us do this for normal. Okay. So your predictions will be pred underscore normal and pred underscore not normal. Okay. Similarly, your actual underscore normal, actual underscore not normal. Is this okay? So what is prediction normal and actual normal? Prediction is normal. Tell me.
60.
60. Okay. Similarly, prediction not normal, actual not normal. How much it is?
212.
200 plus 3 plus 8 plus 1. Right? It is 212. Okay. Now tell me this. Prediction is not normal, actual is normal. How much it is?
40.
40. What about the other one? Prediction is normal, actual is not normal. 55.
Yes, sir.
So what are you doing? You are micro averaging. You are converting a 3-class problem into a 2-class problem, right? You are considering the other 2 classes, not that particular class. That's all. If it is urgent, you are calling the other 2 classes not urgent. If it is normal, you're calling the other 2 classes not normal. That's all. Is it fine? Okay, let's do this for, we do have some time. Let's do this for the other class also. And then there is something else also we should see. Okay, let me do that here. So this first one, what did we do? We did it for urgent. 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 And what values we got? So we got 8, 11, 8, 340. 8, 11, 8, 340. Okay. So what about the next one? It will be actual spam, actual not spam. Oh, just a second. So what are the values? Actual spam. What is the value? 200, 33, 51, and 83. Check the values.
Is this the only way, or is there another way? You mentioned
There is another way, but let me not confuse it, because if I tell you the other way, the answers will be very different.
Okay.
And I'm going to give you some practice problems based on this. If I teach you the other way, people will confuse. And even now in the assignments also, many people have used different methods of solving the assignment, and eventually you get different answers.
But for this course, we will be using only this method.
Yes, this is called micro averaging. Okay. Okay. So now you calculated precision and recall for individual classes. What are the individual classes? Urgent, normal, and spam. So now if I ask you to calculate precision and recall for the entire model, not for a particular class, how will you do it? How will you do it? So this is spread. Let's say, let's call it, let's not call anything. Just call spread and actuals, right? So these are the spread. These are the actuals. Okay. How will you do it? I want you to calculate the precision and recall of the entire model, not just individual class. So what will this be? Add everything. 1 plus this plus this. Okay. Similarly, copy paste. Right. Now what will happen? What is your precision of the entire model? True positive by true positive plus false positive. Is it clear? Is that fine? So you can call this as, let's make it a little more spread. Say yes. Spread underscore no, something like that. So it'll be easy for you to calculate the true positive. Act underscore yes. Act underscore no. Right? So prediction is yes, actual is no. What is this? False positive or false negative?
False positive.
False positive.
How? Prediction is yes, actual is no.
Uh,
False positive, sir.
false false positive.
Yes, false positive. This is actual yes, prediction no, false negative. Okay. So with this, you will be able to compute the precision recall of the entire model. But when it comes to accuracy, from where will you calculate? From this? The answer is no. You will have to calculate it from here. So what is the accuracy? How will you calculate the accuracy? Tell me. The diagonals, sum of the diagonals divided by sum of all these guys. So 73% is your accuracy.
That can come from the final table also, no?
It can, but the numbers will be very different. But this is
No, 268 will be the same, at least for the accuracy part. That cannot be different.
let's check it. So what you say is,
Because the
let's see,
small three
268.
tables are always taking the diagonal, right?
Let's see 268 by 76 divided by sum of all these things. This is what you say.
Okay.
Is it same?
No, okay.
It is different. So this will lead to wrong metrics. So therefore, this is only used for calculating precision and recall of individual classes. So this is called micro averaging. So here your actually using the micro part here, and then you're averaging it out for the entire model. Whereas accuracy, you have a straightforward method to calculate it. You don't have to get into all these things. Okay. So this batch is very, very active and interactive. Couple of batches before, what we used to do is we will cover logistic regression and DEA in one class because people hardly ask any questions. Whereas this batch is very, very interactive. Malolan gave me a clear heads up. He said, don't take topics, take time to cover topics. And therefore, we are doing it slow here. Okay. So as far as logistic regression is concerned, let me give you a few more practice problems that are not available on the course portal in the non-graded section. Okay, so if you solve it, your confidence on logistic regression will go up. Furthermore, did you have questions on logistic regression in quiz 2?
Yeah, 40% of the was on that.
Oh, 40%. Already, did you already cover all these things?
I made a stupid mistake in the calculator.
Uh,
Whole thing went off. E power minus x, that minus did not go in.
Oh, okay. It happens. Sir.
Stupid,
It happens.
but then that's okay. That's all right.
Yes, yes. And did you have my multi-class problems for quiz 2 or just binary class?
No, it's a binary. It's a binary, and
so for end term, you can expect a multi-class problem. Okay.
That's okay.
And it will be very, very similar to what we saw. Okay. So
we will do micro.
Micro.
What? No. Averaging, right?
Sir, can you repeat?
Was it called micro averaging?
Yes. It is called micro averaging. There is another way by which you can calculate accuracy, precision of individual classes.
Enough confusion.
Yes, enough confusion. So I will not bother you with that. Even I don't remember that name. I forgot. So this is the common thing that I use for calculating precision recall. Because the problem is in industry, we don't calculate this manually, right? We just give it to the package.
Everything comes with the packages.
Yes, the packages we import and we get the metric. We just have to interpret the metrics.
Yes.
We don't have to remember how random forest works, how XG boost works. That is only for interview purpose.
No, it's if you're developing a package, yes. Otherwise, it's all. There is no need to keep reinventing the wheel, right?
Yes.
But usually in industry we use the F1 score. No?
F1 score, yes.
F1 score is more used actually.
Yes, there is one more metric that is even more useful than F1 score. It is area under the curve, AUC curve.
Area under the curve, AUC, right? Yeah.
Yes.
Two things,
yes.
Because the tool gives you these things actually. All the ML tool, F1 score and the AUC.
Sir, as a business analyst, what is more important is you will have to identify which metric is more important. So we saw two examples, spam classification and cancer classification. In spam classification, precision was more important. In cancer classification, recall was more important. There will be certain problems where both are equally important. In that case, you will go for F1 score because F1 score, it uses a harmonic mean of both your recall and precision. So it depends on problem to problem. As a business analyst, you will have to sit and understand which is more important, which one will have more impact. Do you have to reduce false positives or false negatives? Okay. So for the next week, I request you all to view DEA and come. So if you watch the 2 weeks of data envelopment analysis and come for the next live session, you don't have to study it again for the end term exam. Just watch the videos carefully, take notes and come for the live session. We will finish it off DEA next week itself. You don't have to sit and study again for the end term exam. Right? That promise I can give you.
Which topics?
Which topic?
Yes, I'll tell you. It is week 8 and 9 or 9 and 10.
Okay.
8 and 9. So 10 and 11 are conjoined. 8 and 9 you watch and come. So that you will have a lot of questions to ask me. Else, it will be a monologue where I am going to be asking what is efficiency, what is efficiency frontier, what are the constraints, primal, dual, shadow price. Okay, it is slightly difficult, but the exam part won't be very difficult. Okay, because you already have all the complications in the first 7-8 weeks. So the last few weeks, the topics are hard, but in the exam it will be relatively easy. Okay. All right, guys. Thanks for your patience. I'll stop the live
Thank you.
session.
Thank you. Good night. Yeah, very good.
Thank you, sir.
Thank you, sir.
Thank
Thank
you.
Thank you, sir.
Thank you, sir.
Thank you, ma'am.
Thank you. Bye.
Bye.
Sir, 1 second.